Hello, welcome, welcome. So, in this series, we're building a data oriented C compiler in C, and we're trying to do it incrementally. So far, all we can parse is literals and plus and minus. So we can add and subtract numbers, and that's pretty much it. But we're trying to build out the whole pipeline all the way to the end. So I'm hoping to get the parsing done in this episode, and then we can write tests like this. So we can parse this string and produce an abstract syntax tree as output. And in the previous episode, we got the pretty printing of the abstract syntax tree working. So now we just need a parser. So finally, we get to go to parsing. So let's just dive in. I think actually I'm just going to put the parser into this file for now with the tests. And then we can move it into its own file a little bit later. Yeah, let's get started. By the way, thanks for everybody that voted for the community posts. That gives me a good idea of what to do. The nice thing about episode 5 was that it was 2 hours of footage, so 2 hours of actual programming work done that condensed down into 40 minutes. And I think I made 3 edits. Everything else was done by scripts. So that is amazing. But the silent parts were silent for maybe a little too long. So I might try and do some voiceovers in this episode, but I can't promise anything. If it takes too much work, I'm just not going to do it. And I don't know about music. I could maybe do music, but most people didn't vote for that. They voted for trying to explain a little bit better what I'm currently working on. So I will try and do that. So let's dive right into the code. Yeah. So the AST already has the tokenizer on it. And I did that because we need the tokenizer in order to pretty print the AST. I wonder if we should refactor the tokenizer a little bit. Now might be a good time to do that. Let's do that. What I want to do is split out the functionality for the source into a separate object or a separate struct, essentially. Oh yeah, I was going to fix this. Let's fix this first. That just involves moving the buffer and the end, and maybe renaming the buffer to start to the beginning of the arguments here. So let's do that. Okay, and I was going to do that also in the AST, but I'm not going to do that right at this moment. I'm not working in that file currently. Just trying to do the Boy Scout rule, where if I see something that's dirty, try and clean it up while I'm looking at it. Okay, so what was I doing? Now I'm distracted. Right, I was gonna pull a source out of here for the tokenizer and make a separate structure. That's not quite what I want. That's basically what I want. Yeah. That'll be a double indirection. I don't want. So I did figure out how to do voiceovers. It might be a little bit tricky, but yeah, I'll see what I can do. Right now, I'm just fixing up all of the references to the sources and finishing that refactor. just moving things around and renaming them so that they're part of the source object instead of the token or the tokenizer. Just moving things around, arranging things so it kind of flows well. Now I'm fixing up the references in the abstract syntax tree. So this was the point of this refactor was in the AST, I want to store a reference to the source, not the tokenizer. Because I don't need to tokenize with the AST, but I do need to refer to the source in order to get the text content of the tokens in the AST, right? So I think it's good to separate that because the tokenizer is specifically for tokenizing, but then the source is specifically for representing the text of tokens. So yeah, just finishing up that refactor. Now I think I've moved on to the tests here. Yeah, just refactoring the tests so that they reference the source as well. All right, we've got passing tests for that refactor, which is exactly what we want. So we can continue working on our parser here. It's going to contain a tokenizer and the abstract syntax tree and some more elements that we can use. Here I am trying to think of like how I want to handle tokenizing within the parser. I kind of go down the wrong road at first, putting a duplicate of the tokenizer methods on the parser itself, but I quickly figure out that's probably not the best way of doing things, and I revert that change. Next, I'm making the tokenizer a little bit nicer to use by adding in a peak token method, or a token peak rather. And I also did a little bit of refactoring in there while I was there. Here's where I remove those methods and change my mind. Now I've decided to work on doing expectations instead. And that I like a little bit better. So then I decide instead of like checking the token type, I'll just return the next token type and then check that independently. Now I'm working on using those methods within the parse method. And I'm saying method, but I mean function. You know what I mean. I'm so used to Go. Now I'm checking the tests and trying to get everything compiling again. Okay. So I have parsing of integer literals working. Let's go through the code a little bit. So the tests are simplified a fair amount because now we're just parsing. So this is how it would be used. You would initialize the tokenizer and the abstract syntax tree, and then pass it into the parser. The parser sets up a new parser object, and then currently it just parses the primary. A primary is an integer, or it could be a bunch of other things, but for now, it's just an integer. I have a helper function that gets the next token type, and it just peeks into the next token to see what that type is, but it doesn't consume the token yet. And then I have expect token that does consume the token. Expect token will make sure that the token is what's expected, and that just cuts down on bugs. And then we've got the so the expect token will grab the next token from the tokenizer and check that it's the correct type. For now, this is how we'll handle errors, but it would be nice to queue up the errors and show multiple errors at one time. We will handle that in the future. For now, we'll just exit when we encounter the first error, because that's better than nothing, but that's certainly not the state that it'll end up being in the end. So I also refactored the tokenizer a little bit, and I made sure that they all start with token just to be consistent. And then these start with source because they're methods, so to speak, on the source object. And these are methods on the tokenizer. So I split token next into token peek that just looks ahead to see what the next token would be, but it doesn't save it. And then token next does save it. So it just invokes token peek and then saves that to the tokenizer right here. So that's there. What else did I do? Yeah. So I think that's everything. We're able to parse just integer literals for now. Let's work on parsing simple binary expressions. Let's do that. So now I'm splitting out a way of basically inserting nodes. I didn't have an invalid node, so I added that. Now I'm adding a way to set the token on a node that's been started. Now I'm modifying the tests to invoke parse. Now I'm modifying things to return a node ID if necessary, adding in the add and sub to a switch statement. Okay, so I have parsing the binary node here working, sort of. I'll get to that in a moment. So what we're doing is starting a new node, and this is the problematic part, but we start a new node. It's incomplete, so we just tell it there's an invalid token there. We'll find the token later. We parse the primary on the left-hand side, so that'll be an integer. So we get that. If it's an add or a subtract token, then we set the token of the currently open or currently started node to the add or subtract token, and we consume it here. And then we parse another primary and end the node. But if a add or a subtract is not seen, then we end up with the returning just the left here. And what we need to do is actually remove this node because we don't actually need it. Because if we're parsing just a literal, then that's all that should be in the tree. We shouldn't have binary here. So we'll need to figure out how to handle that case. The other thing that I did was for the, what was it? I think it was in the AST. Yeah, I made it so that AST end node and AST add node both return the node ID. That way I can return the node ID from the parse methods. That's not required right now, but eventually it will be useful to know the node ID returned from parsing the binary or whatever. So I just happen to know that I'll need this node ID eventually, so I just put it in there. So that's that, but we need to deal with not inserting this node quite yet. So let's figure out how to do that. So I decided to kind of make it into a reservation system instead. So at first, I'm just using the node context as a handle on kind of like a bookmark for where to insert the node. That's opposed to like removing the node after the fact. I just hold off on inserting it until I know I need it. And here I'm trying to figure out, off by one errors and other things. Trying to get the syntax right. Here I'm like playing around with modifying end node to handle reservations. I decide against this in a moment. It's just kind of overloading this function to do too much. So here I'm separating that into a separate function. Here I'm kind of hemming and hawing about like the best way to do that. Now I decide that overloading node context is not a good idea, so I change it to node res, short for node reservation. And I'm modifying parse. Trying to fix a bug in the insert node here. Okay. All right. So that was a little tricky. Let's go over what I did. So I have this idea of a reserved node. So then it can kind of, you can kind of think of this as like a bookmark. It reserves a spot in the abstract syntax tree, and then later I can insert into that reservation, and that solves that. So in the last episode, I was pretty happy that we were able to figure out how to put the abstract syntax tree, the nodes array, in the correct order so that the roots are at the beginning of the array and the children are at the end. The issue then is that in some cases, you need to be able to insert a node in order to do the parsing, like build the tree properly. Because sometimes you want to insert a node and sometimes you don't. So the way that I thought of to handle that case is just to do a memory move. So in the AST, when you're inserting a node, it starts the node, but this will be at the end of the array. So then I just move the memory over and then put the node there instead. For the most part, we shouldn't be moving very much memory because we'll be working at the end of the array as we're parsing. So I don't think this is going to be much of a performance hit, but it's not super ideal. If the nodes array is backwards, then iterating over it from root to leaf is going to be slower. However, we wouldn't need to do this memory move. So I think we're going to be iterating over the tree at least twice and only building it once. So I think it's better to pay the penalty here rather than when we're trying to traverse the tree. So I think that's what we'll do. If it turns out that when we're traversing the tree, we want to traverse from leaf to root, then perhaps we can revisit this memory move and reverse the way that we're producing nodes into the tree. But for now, this will work just fine. So, yeah, we insert if it is an add or a subtract. If it's not, then we just return the left-hand side, which is the primary, and then we end the node here. I did some speculative work on like how we would bump the reservation to the next node if we needed to loop. I'm not sure that this is the way to do it. You might need to skip over the subnodes. I'm not sure. At any rate, we don't need this yet, so I'm just going to remove it. Once we do parsing, then this will be important. But we can rewrite this then once we know exactly what our needs are. So I will just remove that. Yeah, I'm not 100% happy with the reservation system, but it's good enough for now. So right now we're just assuming that there's only two terms, two add-ins, I guess. So next we need to be able to parse 3. So that might require extra doing. Let's see. Okay, let's work on that then. So yeah, now we need to work on producing the nested structure here. So that'll involve inserting multiple ones. And actually, it might be quite simple to do. Let me just try something here. Instead of parse primary here, let's just try parse binary. And that worked. Okay, it's as simple as that. So now we can recursively add onto the right-hand side of the tree just by recursing here. And if it's just a leaf node, then it will hit this and then default and return here. Yeah. So the other thing that we need to do is make sure that when we're parsing, the last thing that we parse should be the end of file. Basically just like that. And everything passes. Excellent. Excellent. So we're able to handle expressions of arbitrary length. And actually, now we can do test cases this way. Yeah. So the next test case is this one here. Now, what would that's basically it. This is actually it. Let's just uncomment this because we're going to be using it now. Excellent. Just making sure that the test cases actually fail. That way I know they're actually doing something. Okay, it appears to work. And so we've simplified this and we can add a lot more test cases really easily, which is great. That'll make adding features to the parser a lot easier in the future. So now the big issue is that our parser is here. So let's just move this out into a separate file. Excellent. So we have the make file now, including the parser.c. We've got the parser in this C file here. And we've got just this parse method in here for now. If in the future we need more methods than just this, then we can move the parser struct into here and do that. But for now, the parser is just a bunch of static methods, or static functions really. And then this is the only public one here. So I think that's everything. Yeah, what we need to do next is, well, looks like we got to fix this up. I'm just fixing up the main method in gauzy.c. So what I'm wondering is if we should integrate the parser into here and get code gen working. I have essentially 10 minutes wall clock time to do that. I don't think I can do it in 10 minutes. Yeah, it's probably better to do the code generation properly. So I'm not going to do it in this episode. I think we can do that in a future episode. So in this episode, we got a parser working, a recursive descent parser. It doesn't handle operator precedence yet, so we haven't moved on to Pratt parsing, but that will be in a future episode. For now, it does parse, and it parses the syntax that we currently support. We don't have code generation yet, but we'll do that potentially next time. And we did a whole lot of refactoring as well. So yeah, thank you very much for supporting this channel if you do. And yeah, thank you very much for watching. I hope you have a great day. Bye.